I recently bought a Graaff Generator. This has a rubber belt which goes round a nylon roller at the bottom, which is in permanent contact with a metal comb. At the top there's a metal roller and another comb. The generator uses the triboelectric effect, which is a type of contact electrification, generating electrical charge by contacting and separating certain dissimilar materials, the same as rubbing a balloon on your jumper. The top of the generator accumulates positive charge and the bottom accumulates negative charge. This desktop Graaff generator can generate around 100,000 volts DC, which allows us to see a visible spark between the positively and negatively charged ends of the machine. Although it can produce very high voltages, some bigger versions up to 5 megavolts, this is only at very low current levels, making it safe to touch. And you've probably seen these sorts of demos before in a high school classroom. Opposite charges attract each other, while like charges repel each other, the same as the north and south poles of magnets. So if I hang this negative probe loosely in my hand, we can see it initially repel the positively charged top of the generator until there's a spark which brings them to the same potential, until the top of the generator accumulates positive charge again and the bottom negative charge, at which point they repel each other. Placing some aluminium foil pie dishes on top of the machine and turning it on causes them all to become positively charged and repel each other, which gives us a rather dramatic effect. The machine was also provided with a container that mounts on the top containing foil balls, which shows the same effect but with less mess. But I want to use this as part of my Great Ball Contraption, which passes ping pong balls along from one stage to the next. I've already built an Archimedes screw, where the screw doesn't actually turn but it still works, and a Commander effect staircase, so check those out in my channel. So let's see if we can use high voltage to move ping pong balls. Well, not much luck there, probably because they aren't conductive. I bought a tin of nickel screening spray, which is used for shielding things typically in RF applications and also audio applications, so we can spray this on plastic and make it conductive. It was quite expensive though, at around £36 for a tin. So I painted up my ping pong balls. I've only done 3 for now so we don't waste any, and they are conductive to metal and also stick to magnets. So let's try that again, and we can see that that's much better, almost as good as the foil pie dishes and the foil balls in the container. First of all, I'm going to try a very simple experiment that you may have seen in other YouTube channels. I've got a glass dish and some aluminium tape, and the idea is to make a high voltage ball accelerator. I put a cross of tape on the top surface, and all of those contacts are linked together. I put another cross of tape on the bottom of the dish, and that makes 4 more contacts which are isolated from the first 4. I tried to avoid arcs between the 2 sets of contacts by cutting the corners to point shapes, then that leaves at least 20mm between the 2 sets of contacts. One set of contacts is attached to the negatively charged bottom of the Graaff generator, and the other set of contacts is attached to the positively charged top. So that leaves us with alternating positively charged and negatively charged contacts. So let's see what happens when we throw in our nickel-plated ball with the machine turned on. Since the ball is now conductive, when it touches the positively charged electrode it becomes positively charged, and the positive charge then repels the positive charge of the electrode. It's also attracted to the negatively charged electrode, so it moves towards it. At that point it becomes negatively charged and repels the negatively charged electrode, becoming attracted to the next positively charged electrode, and so the ball moves round in circles. My electrodes are a little bit too close though, so I occasionally get some arcing that you can see better in the dark, but ultimately this shows that we can move our nickel-plated balls with a high voltage. So now that works, we know we can make some custom 3D printed parts and try and make a linear ball accelerator which will be part of the Great Ball machine. Thanks to 3D Fuel for the filament for this project and lots of other projects, so check out my channel for more 3D printed projects and check out 3dfuel.com. I attached several printed parts together to make what looks like a long piece of guttering. This has feet on the bottom, and along the edge I've made lots of holes which I can put bolts through to attach to electrical contacts. I want to make the linear version of my glass dish, so I've put aluminium strips, this time further apart at around 30mm, and each one of these will be alternately charged positively and charged negatively. I put nuts and bolts through the holes and then wired each one with insulated wire so they don't arc against the opposing charged terminal, and I used eyelets and a crimp tool to make sure I've got proper connections. So now we have negatively charged terminals on one side, positively charged terminals on the other side, nicely separated. I also left a gap at one end so I don't get zapped by 100,000 volts when I throw the balls in. So, as I did with the glass dish experiment, one side is wired to the top of the Van de Graaff generator for positive charge, and the other side is wired to the negative charge at the bottom. To start with, I'm going to place the ball in the middle and leave it still, and then turn on the machine and see what happens. And we can see that repels the ball to one end, and this is really similar to the glass dish, with the ball getting positively charged, being attracted to the next negative terminal and repelled from the positive terminal, and then continuing all the way down. This seems to be working pretty well, and you can see I'm not really pushing the balls in there, I'm just placing them on the end, and as soon as they cross the first terminal, the machine starts to take effect. It also works in the other direction for the same reasons. So let's try a slight incline and see if we can push the balls uphill. And a slightly bigger incline. So not quite as good. It almost makes it but rolls back the other way, and of course when it does so, the machine actually pushes it in that direction as well, which makes it even more difficult. Now it's time for a quick ad from the video's sponsor, which is Phantom Wallet. Phantom Wallet is available in a number of sizes and finishes. There are two lineups, Phantom R and Phantom S. Phantom Wallets include a special mechanism that fans out your cards for easy access. There are lots of accessories for customization available which attach to Phantom Wallets, such as a coin holder, money clip, key holder, a multi-purpose silicone band, ID holder and tracker. Phantom Wallets are very stylish and also compact, so they reduce pocket bulge considerably. Check out Phantom Wallet at the link below in the video's description box and use my coupon code BRUTON for 10% off. So this works pretty well as a stage of the ball machine, but I need to push multiple ping pong balls through all of the stages, and I don't really want to have to coat all of them with nickel, and the coating will probably wear off in the other machines as well. So it's time to build a clever ball exchanger that'll exchange normal balls for nickel plated balls and back again at the end of this stage. So I 3D printed these 4 sections which all glue together to make one big piece. This makes 2 ramps, and I've also made some edges to stop the balls falling off the back, and that allows one ball to roll back to get reset and used again, and the other ball to bypass the machine completely, exiting from the other end. So the nickel coated ball will get pushed along by the high voltage ball accelerator and then sent back to the beginning where it will get lifted up again, and that one will go round and round and round. The normal white ball will just bypass this stage and exit at the other end so that it can go on to the next stage of the machine. I've made a lift shaft for the start of the machine which will pick that nickel plated ball up and tip it back onto the top rail again. And it will do that by having a little stick sticking out that causes the lift to tip and causes it to tip perfectly into the top rung. I left a recess in the lifter for that so it doesn't stick out and stop the ball rolling off, and when that's in the lift shaft it should work pretty well. So now we just need something to lift it up. Most elevators or lift shafts have a riser above them where the motor lives that lifts the lift up, so I've built one of those which is going to house a servo with a pulley on which will do about a quarter of a turn to lift the lift up and also cause it to tip. That lives just here, and that means the pulley aligns perfectly with the top of the lift platform. To make sure the timing of both balls is correct, I've made a back panel which has another servo, and it has a little platform which moves out of the way, and that stops the ball falling down until we're ready, and that means we can alter the timing to get both balls to exit at the other end just when we want to. Also left place for a proximity sensor so we can sense when the ball has been inserted. I'm going to control all of this with an Arduino Uno that's linked to the servos and also the proximity sensor. I don't want to destroy my computer with static electricity, so I'm using a USB power bank to power the Arduino, and the servos are powered from batteries. So now when I insert a normal ping pong ball, it's detected by the proximity sensor, which spits out the nickel coated ball, and that runs down the ball run and goes back to the beginning. The white ball just goes through the bypass and exits throughout the other end. I'm pretty happy with that so far, and of course from the front you don't see any of the balls going backwards and forwards. But before we reconnect the Graaff Generator, there's just one extra piece we need to stick on. Well, that seems to work pretty reliably. I'm pretty happy with that. It's a really good demonstration of electrostatics and also cheap illusions. We do need to do something about the feeding end, to put a hopper or a big scoop on so that you don't have to poke the balls in there. But that will be sorted out when we know which stage of the Great Ball machine is actually going to feed it. And I need to revisit the calendar effect staircase because it's not very reliable. And we also need to get that screw out and probably build some more stages and string them all together and put scoops in and things so the balls get passed on reliably. So I'm going to publish all the CAD and code for this. If you'd like to build your own, you can find that in the description to this video. There's a link to my GitHub, and all of that is open source. So if you'd like to support me through Patreon or YouTube channel membership, those links are in the description as well. And patrons and YouTube channel members can get access to all the videos up to a week early and sneak peeks and pictures of what's coming up and be part of that discussion. Alright, that's all for now.